part 2, we will be talking about different types of steering mechanism. When the vehicles were invented in the previous century, turning pairs were supposed to be the most fundamental ones, which means a small stub axle passing through P and the center of the wheel, and a similar stub axle passing through Q and the center of this wheel were pin jointed at the point P and Q, which means in the top view you actually were placing a pin at the points P and Q, because of which your wheels could actually rotate as seen from the top view. Now, a mechanism where all pin joints are used was originally derived or designed by this designer named Ackermann. It has, if you notice, only turning pairs. Now the turning pairs have a drawback that they do not continuously satisfy this fundamental law of correct steering, which means when your vehicle was going straight and when you start steering it to the right, notice that phi and theta are the two angles which are changing. At that time, not in all the positions that the two center lines intersect at I, and not in all the positions that this I lies exactly at the line passing through the rear axles. This happens only during the extreme position whose diagram we have shown. So that is considered to be a drawback, that the steering gear mechanism will satisfy the law of correct steering only when your full steering is rotated. Graphically, if you are interested in actually calculating these angles theta and phi, because we have already built the chassis, we are supposed to consider the equation cot phi minus cot theta, actually substitute it as a ratio of the chassis dimensions what you make, and use trial and error methods to find out the exact combinations of these two. Remember, right hand side is constant. So if I keep changing theta, this is constant, phi will change. So theta 1 correspondingly substituted in this equation and get phi 1. You could argue that you could do it the other way around also, which is completely fine. Somebody could assume phi 1 and therefore get theta 1. Then assume the next angle theta 2, substitute it in the correct steering equation and derive the second equation phi 2, and continue this till we get n different values of the pairs of these two.